This is the mini lesson for 2.6. The distance d in kilometers Carrie runs in a marathon varies directly with the amount of time in hours spent running. So remember, the order is important. It just said the distance varies directly with time. So I'm going to set this up off to the side. Assume that Carrie's constant of proportionality is 23. They want me to write an equation representing the proportional relationship between d and t, then use my equation to answer the questions. So d is first, that's the variable I want to isolate. So I have d over t equals 23 over 1. Means and extremes. 23t equals 1d. Here's my equation. So I am now going to use this equation to answer these other questions. So I'm going to rewrite it. And it doesn't matter if I write 23t equals d, or I could put the d over here. So I guess I'll try it both ways. If Carrie runs for 1/4 of an hour, how far will she travel? 1/4 of an hour is time. So d equals 23, and I'm going to change that to a decimal, times 0.25. So if I multiply 23 times 0.25, d equals, I get 5.75. Now I need to know, what is d? D is my distance in kilometers. So that means in 1/4 of an hour, she would run 5.75 kilometers. If Carrie runs, I'm going to do this one with the d second, just so you get to see two different ways here. If Carrie runs 1.5 hours, so that's my time, so it goes in place of time. I'm going to use 1.5 equals d. So now I'm taking 23 times 1.5, and I get 34.5 equals d. And again, d is in kilometers. So she would run 34.5 kilometers in 1.5 hours. Okay, now they could also give me the kilometers and ask me to find the time. So again, I'm going to do this with the variable both ways. So I'm going to say d equals 23t. Keep going back to my equation. Now if she runs 57.5 kilometers, that's the distance. 57.5 equals 23t. I'm going to railroad track this. There's nothing I can do over on this side of the equals. There's nothing on this side. So I want to isolate my variable. This means multiplication. We undo multiplication by dividing. I have to divide both sides by 23. And when I divide both sides by 23, 57.5 divided by 23 gives me 2.5. And 23 divided by 23 is 1t. And again, I'm going back to the top to see that my time is in hours. So that means 2.5 hours. Okay, now again, I'm going to use this equation, but I'm just going to put the d on the other side to show you it doesn't matter which way you do it. How long would it take Carrie to run 10 kilometers? 10 is going to go here, in place of my distance. 23t equals 10. I can't do anything on either side of the equals, so I'm going to isolate my variable. Divide by 23, divide by 23. If I take 10 divided by 23 and round to the nearest hundredth, I get 0.43, and this gives me 1t. And again, we said time is in hours. So almost 1/2 of an hour. What do you think the constant of proportionality represents in this problem situation? So I'm going back. D equals 23t. So we know the constant is 23. From my equation, the way I always set this up is the variable that's attached to the constant, I'm going to put a 1 there. So I'm going to say for every 1, t is hours. 1 hour, Carrie, and we're talking about Carrie running, so Carrie runs. So if I put 1 here, 23 times 1, then the distance would be 23. So she runs 23, but now I need my label, kilometers. So you can see I'm using that constant, and I'm using that 1 that would be underneath. If y and x have a proportional relationship, then the constant of proportionality, k, can be expressed as k equals y over x. This equation is equivalent to the equation y equals kx, where k is the constant. We looked at this, I believe, in lesson 2.3, that we can take this equation and change it into this by isolating the variable. If I want to get k all by itself, I need to get rid of x. It means multiplication. I undo it with division. Divide by x, divide by x. Then I would get k equals y over x. So my constant is always equal to y over x.